So we are back, yeah? So now, let me share my screen again so we can begin. Can you see the screen now? Hello?
Yes.
Okay, good. Now, let us begin our data description. Now, under that description, we're looking at measures of central tendency and measures of variation. So under this, that's what we focus on. So let's start with the measures of central tendency first. So these measures are used to describe the center point of the distribution. So use it to describe the center point. Now, the most common measures of central tendency we use include the mean, median, mode, and mid-range. Now, of course, the mean is the average of the distribution. We find it by summing all the data values and dividing by, number of values. So we can say that the average age of students in a college is 25 years, something like that. So that's mean. Or the average income of a teacher, is so and so amount. So you just give us the average. Now the median give us the middle value of distribution. So the value at the middle. So when we say that the median income of a college professor is $65,000 a year, for example, what we mean is that half of them make $65,000 or less, while the other half makes $65,000 a year or more. So usually we use median for income because it gives us a better estimate of the income. Since income is skewed, you use median for any distribution that is skewed, whether it is skewed left or right. I just explained to you what the skewness is when we were discussing the shape of distribution. Then mode give us the value with the highest frequency. We can use it we can say about the most preferred stock, for example. That means the one that most people bought. The most preferred model of a washing machine, and the most preferred candidate. All these are modes. They are modes. They represent modes. So mode, the one that occurs most often. When it is only one number that occurs most often, we say that it is unimodal. If it is two modes, we have a bimodal. So if a data set have more than two modes, we say that it is multimodal. Now for mid-range, this is just a rough estimate of the middle value. So we get it by adding the maximum value plus the minimum value, then dividing the result by 2, give us the mid-range. So all these things these are the computational formulas we use. Now, remember, what we are doing tonight will be for ungrouped data. Tomorrow we'll do the group data. So for ungrouped data, it's very simple. So this is the mean. We use the X bar to represent the sample mean or average. This symbol here represents sum of X. S represents all the data values divided by N. N represents the number of values in a data set. For median, we just get the middle value, and that will give us the median. And for the mode, we get the value with the highest frequency. Okay. Mid-range, you just add the lowest plus the highest divided by 2. So let's do an example. We have okay. Now this is for the median. Okay. Now for measures of variation, we do examples. Let me just explain the background. For measures of variation, this tells us how far a data value has strayed away from the center. I'll give you a typical example. If the speed limit in a road is 40 miles per hour and you are going 45 miles per hour, you didn't stray very far from the average speed. But if you are going 55 miles per hour in a 40 miles per hour, that's when the cops will notice you. And then, so that one is straight very far away. So that's what these measures help us to see how far the data value have strayed from the center point, from the mean. So this measure includes the range, the variance, and the standard deviation, and also the coefficient of variation. The range simply means the maximum data entry minus the minimum data entry. The variance and standard deviation, they give us, how data distribute itself about the mean. So usually we need the variance to get the standard deviation. So that's why most time we make our decision based on the standard deviation, because we need what we need variance is just to give us the value of the standard deviation. Then the coefficient of variation represent the ratio of the standard deviation to the mean. So we use it to compare the degree of variation from one data series to another. I'll give you an example. Suppose that you need somebody who lives in New York City and is making $70,000 a year, and then somebody who lives in Baltimore City and they're making $50,000 a year. One might think that the person in New York is richer than the person in Baltimore City. But that is not always the case, because if you factor in the cost of living in New York City, the cost of an apartment alone, compare it to the cost of apartment in Baltimore City, you see that they're almost the same, even though the amount of income is different as in numerical terms. But if you look at their standard of living and you see that they are almost the same level. When you factor in the cost of living, cost of rent, cost of apartment, transportation in New York versus Baltimore, So we use coefficient of variation to compare things like that. So now here is the computation formula for variance. Sum of x squared minus sum of x squared over n divided by n minus 1. And for standard deviation, square root of variance. Now I must say this, in statistics, we might have different like for example, we have many formulas in statistics. Now, the variance can have up to 3 different formulas for finding the variance. The same thing with the mean. So I recommend that you stick to the one we use in the classroom so that you don't get confused, okay? Now, the coefficient of variation, the formula is standard deviation divided by the mean times 100. Now, we're ready to do an example. It says here that an experiment was conducted to measure the effectiveness of a new procedure for pruning grapes. Each of the 13 workers sampled was assigned a task of pruning an acre of grapes. The productivity measured in worker hours per acre is recorded below. He said, compute the following: the mean, median, mode, and mid-range. Let's play our results. Let's start with the mean. Now, each of these data values represent x. For example, this 4.4 is x1, 4.9 is x2, 4.2. So they all represent x. So the best way is to put them in a tabular form. So you can see that mean is the sum of all this. According to the formula, you can see that the formula says that mean is sum of all the x divided by n. So, so let me get the put them in a table form, and then we can get the mean right from there. Just give me 1 minute. Let me put it out from where I left it in Excel. I can just get the total here. Yeah, get them down. So the make workers productivity, I'll call this the serial number. Okay. Okay. Let me just I just want to copy it so you can paste it in a place. So we have this right here. So you can see the number. I put the numbers in. See, all of them are in. So there are 13 of them. So the mean says add all. If you look at the formula, it says S bar sum of x over n. So add all of them and divide by the number of items. So if you add all of these numbers here, you add these numbers here, all of them, you get a total of I have it here 59.3. You can use the calculator to double check this. You add all these numbers. So based on that, mean become equal, according to the formula says, sum of these numbers, which is 59.3 divided by the n, and n is number of items. So this is, they are all of them. There are 13 of them.
So I'm not seeing your screen.
You're not seeing the screen?
I'm only seeing the Excel. I don't know what you're saying.
You see it now? How about now?
Yeah, I can see it now.
So you can see it. Now the mean, to get the mean, I put all these numbers in a table form here. So to get the mean, you add all these numbers. So if you add all of them, you're gonna get 59.3. And how many of them? There are 13 of them, as you can see from here. 13. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the mean is sum of all of them, which is 59.3 divided by 13. And that will give us 59.3 divided by 13. We got 59.3. Okay, 59.3 divided by 13 was 4.56. 4.56. So I put it right there. What is it? Word documents. So that got 4.53. 4.56. 4.56. So that means interpretation are the workers and average productivity of 4.56 hours per acre. That's how we interpret it. Any question on this? Any question?
Is there a document for this? For this, what you're doing right now? Do you have that in the files? Because I'm trying to find it and I don't see it.
It's not in the file, but you find a similar example in the textbook.
Okay. Alrighty.
Now, so I put all of them in a table so that I can easily calculate it, so you can see the numbers, how many of them, and Next thing is the median. Median, to find the median, you have to arrange them in order from the smallest to the largest, and then pick the one in the middle. So I have it here. I see right here. I arrange them from the smallest to the largest. And there are 13 of them. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the one in the middle is 4.5. Am I right? Am I right?
Yes.
So that means median equals 4.5 hours. So that means that half of these workers have a productivity of 4.5 hours or more, while the other half have a productivity of 4.5 hours or less. So so we have a median there, right there. Now the question says, find the mode. The mode is one that occurs most often. Okay. So our mode here, you will discover that we have this number 4.4, 4.4, 4.4. I'm going to use this. We also have 4.8, these are the number that occur with equal frequency, right? So that means you have two modes. So the modes are 4.4 and 4.8 hours. Sometimes the mode might occur only once, but here it occurred 2 times. So we say that it is bimodal, but it had 2 modes. Yeah. Any question on this? Any question? class? Hello? Hello, scholars, any question?
No question.
No question, Professor.
Look at this one. It says, find the median of the weight listed below. Actually, I'm going to make it find the median and the mode. And the mode. The weight listed below. So, in that case, solution, I will have that. We're looking for the median and mode. Okay. So now in this case, the numbers are not arranged in order. Let's say. Oh, as a matter of fact, before we do that, I forgot this one. We didn't do the mid-range here. Mid-range. Mid-range is the lowest number. Forgive me for that. I just did medium mode. I forgot the mid-range. Mid-range, range, okay, is minimum value plus maximum value divided by 2. So that means in this case, we have the minimum value of the smallest value here is, I believe, is 4.2. Am I right? Am I right or wrong?
You're right.
4.2. So you have 4.2 plus the maximum, largest value here is, I think, is 4.9. 4.9, right? 4.9.
Yes.
And divided by 2. So I'm gonna get it from the calculator. So I say there take you there and do it. Okay, we'll have 4.2 plus 4.9 divided by 2. 4.55 hours. So I got 4.55 hours is the mid-range. 4.55 hours. So that's productive. So it's just a rough estimate of the median. Now, with that, we can now answer question number 2. Number 2 says, find the median and the mode of the weights listed below. So the median is here. They are already arranged from smallest to largest because 2, 2, 3 is smallest. Am I right? 2, 3, 5, 6, 8. Am I right or wrong?
You're right.
So in that case, number at the middle, there are 6 of them. So it's unlike this one where we have 13 numbers and only one number is in the middle. Here we have 2 numbers here. This because they're even. 1, 2, 3, 4, 5. There's no single number in the middle. So in that case, there are 2 numbers in the middle. These 2 numbers will now be used to find the median. So the median becomes 235 plus 268 divided by 2. That will give us the median. So we have 235 plus 268. I'm going to take it to the calculator. So we got 235 plus 268 divided by 2. 251.5. 251.5. 0.5. So half of the weights are 251.5 or less, and the other half are 251.5 or more. And mode is the one that occurs most often. Now you can see this is the mode. 235 occurs most often. Am I right? Or wrong? Am I right? Hello, class?
You're
Yeah.
right. You're right.
You're right.
The mode is 235. So now, what I'm trying to say here is that if you have an odd number distribution, like here where we have 13 numbers, in that case, the median would be a single number in the middle. But when you have an even number distribution, it will be 2 numbers at the middle. That will give you the median. So with this, we can now look at an example of how to compute the variance and the standard deviation. So remember, before I do that, does anybody have a question for me? Any question, any query? Good, there's no question. Now let's look at the variance. Remember that the variance, is it a question?
Yeah. I'm sorry to take you back. We just did mean, median, mode, and mid-range. Can you please explain the mean calculation of the mean all over again?
You talk about the mean?
Yeah.
The mean is the formula is to x bar, which is sum of x over n. So you add odd numbers and divide it by the number of items. So
Okay.
yeah, like here, added odd numbers. We added odd numbers and we get 59.3. How many of them? 13 of them. So the mean is 59.3 divided by 13.
Excellent.
Like 5, 6, yeah.
Okay. Thank you.
You're welcome.
No, thank you.
So now let us look at the variance and standard deviation. Remember, as I was saying before, as I said earlier, the variance and standard deviation and then range, we call them all as measures of variation. So, and the range is the easiest one to calculate because it just beats maximum data entry minus minimum data entry. Now, variance and standard deviation, they have their formulas here. See, this is for variance. This is for standard deviation, which is always the square root of variance. And I explained that we have up to 3 different formulas to calculating the mean and variance. So it's better to stick to one we're using here so that you won't get confused. Having said that, we can look at this example. It says here that the data on European auto sales for the period of 6 years is shown. These data are in billions of dollars. He said, calculate the following: the range of the data set, the sample variance, and the sample standard deviation. Okay. How do we do that? You can see the screen, right? You can see the screen.
Yes.
Yes.
Again, it's always good to put this in table form. So I can put it from where we have it on table form, and then place it here for you to see. So these are the auto sales. Auto sales. Okay. Oh, my mistake. Give me 1 minute. We need more. We need something else here. My mistake. Let me remove this too. Okay. So all these numbers presented, all these numbers they give us here. Here. This is the first X, this is the second X, third X, for X. If you remember, the formula is sum of X squared. So now we're gonna put those X in the table to make it easy. It's always better to have a table of values. This is our X. Okay, it's our X. Now we need to get X squared. Oh, can you see this? Yeah, you can see this, right?
Yes.
Yes.
X squared. Yeah. X squared. Now I'm going to copy this and paste it in a workbook. Okay. Let me paste it in a workbook. Last time when I pasted it, I didn't know that I didn't share it. So you are not able to see it, but tell me if you see this, if you can see this one. Can you?
Yeah.
Yes.
I'm going to move this down a little bit so that we can have enough room. This. Okay. We have it in there. Now, to get our x squared, we have to square each of these numbers. For example, 11.2 squared, let me write this down. 11.2 squared. Right, my pen. 11.2 squared will be, I take you to the calculator, you have, okay, 11.2 squared, give me 125.44. That 125.44. Let me write it down there. Got okay, 125.44. So you square each of them. See, 11.9 squared. So if you square it, you're gonna get
141.61.
Huh?
141.61.
0.61. So following that method, I got the rest of them in this form.
Yeah, 144.
I got 163.84. And I got 179. Okay, 0.56. Then I got 204. 0.94. We add all this.
Professor, it's 0.49.
It's 49. Okay. We add all these numbers here. We add all this one here. You're gonna get 75.6. Let me center it so it can look nice. Center it, all of this. Okay. We add these ones here. You're gonna get 98.94. Okay. So now with this, we can calculate our range. So say find the range. So range is maximum minus minimum. And our maximum here is the largest is 204.49 minus minimum is the lowest. I believe it is 125. 125. Oh, actually, 11. Sorry, I'm using the wrong number. Maximum number here is from the original data we have is 14.3, and the minimum is 11.2. When you subtract this, your calculator, you get 14.3. 14.3 minus 11.2 is 3.1. 3.1. So we got 3.1. 3.1. Okay. Now, next is to find the variance and standard deviation. So the variance becomes, remember the formula for the variance? It says sum of x squared minus sum of x squared over n. So I'll copy it and paste it here. See, sum of x squared minus sum of x squared over n. So this is our x squared right there. We have only 40 minutes left now. The x squared right here. And this is our sum right there. So this one here represents our sum of x squared. And this one represents sum of x squared. Then n is represented by 6. There are 6 of them. So plugging this in, I'm going to open a new workbook so that we can plug this in. So plugging this in, we have, let me open it from here. I'm open it from here. Okay. It will not open. Okay, open. Okay, let me share it. When you plug all these numbers in, you're gonna have, I'm gonna move this away.
Professor, we can see your screen.
Yeah, I'm about to share it now. When you plug all these numbers in, can you see it now? Can you see the screen?
Yeah.
Yes, but
Yeah,
there's
my
nothing on it.
screen.
Plug it in, have variance becomes that okay, becomes the total sum of x squared. If you look at here, you can see right here. So this, which represents this number here, you put it as one, and then put this one here, and for n we use 6. So which takes us back to where we are, becomes equals sum of x squared. I wrote it down somewhere here so I can be looking at it. I'm doing it. 958. Okay, 58.84.94. We got from the table minus sum of x squared. Okay. Sum of x squared. Okay. So which is our 75.60 squared over n. Over n, our n is 6 divided by 6 minus 1. Okay. So I'm going to copy it by 6 minus 1. Okay, that'll give us, if you work this out in a calculator, let's see what our calculator will give us. Okay, let me see what our calculator will give us. All right. We'll have sum of x squared. We got 958. Can you see my calculator?
Yes.
94.
Yes, Professor.
Yeah. It closes here. Okay, minus. All right. Sum of x, which is 76.50. Point 60.
It's 75.60.
5.60. Okay. Squared. Okay. Squared. Okay, divided by. No. Divided by. All right, let me see this way. Okay, divided by, let me put it in the other form. Divided by 6 of them. Okay. Close it. And all of them divided by 6 minus 1. 1.27. Can see right there. 1.276, which is 1.28. So you can call it 1.28 equals 1.28. So I can copy this here and paste it into our main workbook. Can you see this? So that is
Yes.
our variance right there. See? Variance. Now, standard deviation is the square root of variance. So standard deviation becomes the square root of variance. Standard deviation equals to the square root of variance. square root of variance, which is right here. We have a few minutes left. Variance. So after this one, we continue tomorrow, okay? Which is the square root of the answer we got, which is 1.28. Okay, and that is 1.13. So I'm gonna copy it, paste it here. You can all see my screen, right?
Yes.
So,
Yes.
right here.
Excuse me, Professor, how did you arrive at the 1.13? Okay, the square root of 1.
Yeah, so 1.28. Let me show you. 1.28, right? The square root of 1.28. It's 1.13. You can see right there, can you?
Yes.
Okay, good. So like I said at the beginning, we're not gonna spend spend so much time today together. Sorry about that. My schedule is so tight today. But don't worry, I promise you tomorrow we'll spend as much time as you want. Just don't get tired of me, okay?
Good evening, sir.
Good evening.
Yeah, I just want to be sure that you marked me present yesterday because I was in the class.
Yeah, sure. I will do it right away.
Okay.
I'll do it right away. You
I
have few
missed
minutes.
yesterday.
Professor, is it possible that you give us, even though this is going to be in a textbook, is it possible that you give us a copy of this?
Want a copy of this?
Yes, so we
Okay.
can use that as at least a guide for when we do the homework.
Okay. So,
Thank you.
In that case, let me save it. So I can have a copy of this for you. Okay. Let me save this if it allows me. We have 2 minutes. See, I can see your names. I think I can see your names.
Oh,
See, I can see your names for. Okay, let me say for class, for the class.
okay, thank you.
So you can feel free to leave because this I have only 2 minutes left now. So I'll save the copy. I'll upload it maybe by tomorrow. You'll have a copy of this in the online. Sorry, in Canvas. Okay. So
Okay,
now, so we have answered this variance and standard deviation and range. Tomorrow we continue with coefficient of variation. Okay.
Okay.
I will see you tomorrow. After that, then we can now look at group data. So you enjoy your day, and I will see you tomorrow.
Yes, thank you.
You're welcome.
are you taking attendance or you just saw our names?
I saw your name, so I think I'm gonna go with that for tonight. Tomorrow we continue. I have to rush.
Okay, and what's the name of this that you're posting? What's going to be the name of it in Canvas?
Oh, it's gonna be data description.
Okay.
A data description, abridged version. Yeah.
Okay, thank you.
You're welcome. Okay. Have
Thank
a good
you,
night.
Professor.
For your
All right.
evening.
Thank you.
You're welcome. Have a good night.
night.
Good
Good night.
night.
Professor. Hi, Professor. Can you hear me?
Yes. Okay. Yes, but
Okay, I know there's not. I'm going to send you an email. I'm having issues with the OGIVE graph.
yes,
One of their
okay. Okay. Go ahead.
All right.
Send it.
All right. Bye-bye, sir.
All right.